Welcome to this webinar about changing your math curriculum to meet the needs of the Common Core State Standards. In our time together, we will examine the processes and tools available to support changes to your curriculum. I'm Jennie Winters. As the Math and Science Coordinator for the Lake County Regional Office of Education, I serve 45 districts in Northeast Illinois. This includes 265 public schools plus other private schools in our region. I also have the privilege of representing Illinois on a national team to work on curriculum change. So let's get to know a little about those of you who are listening today. What role do you play in your school or district? Please select all that apply. And what levels would you be working with to adapt curriculum for the Common Core? Also, what is your current level of experience in working with the Common Core State Standards for mathematics? We will be pausing to address your questions toward the middle and also at the end of this webinar. Feel free to enter questions so that we can address them at those designated times. There are three types of change necessary to move forward into full implementation of the Common Core State Standards. The writers have advised that we begin with instructional change, as that is the type of change teachers can work with immediately. This webinar will be focusing on the changes in curriculum, which would be a natural progression once teachers understand the elements of instructional change. There will also be other webinars available regarding instructional and assessment changes. One of the things we've noticed from working with teachers in our area was that when we trained them on instructional change didn't immediately happen. And when we talked about that, part of the reason was because they were still tied to an out-of-date curriculum. So making the changes to the curriculum will bring forth more instructional changes as teachers feel more comfortable. There are two sets of mathematics standards. The practice standards are the same grades K through 12, while the content standards differ from grade to grade. There are 8 standards for mathematical practice, while the content standards are grouped in 4 to 5 domains at each grade level. The domains represent a logical progression of mathematics thinking and change as content becomes more complex throughout students' schooling. In your handout, you can find the 8 standards for mathematical practice on pages 2 to 5. These are the habits of mind that are to be cultivated in students as they evolve as mathematical thinkers. Teachers and administrators will need explicit guidance as to what these look like in each unit of study. Although all 8 will be present, not all will be represented equally in each unit, as grade level content may connect more strongly to some practices than to others. The content standards were designed with the idea of focus and coherence. When examining curricula from international leaders, the writers learned that the typical United States curricula differed greatly in this area. Other nations focus on fewer topics, which allows for greater depth of study, while the U.S. curricula was described as a mile wide and an inch deep. The Common Core State Standards were built with developmental trajectories in mind. Grade level standards build upon one another much like a staircase. One idea leads to the next, increasing in complexity at each step. The writers of the standards have been producing progression documents that explain the interconnectedness of the grade level standards. These are key resources in developing curricula at the local level. So the critical areas of focus are the main topics of study for each grade level. In the handout pages 5 to 10, you'll see the 3 to 4 critical areas that were identified for each grade. Although these grade levels include standards that are not mentioned in the critical areas, the majority of instructional time will be spent on the critical topics. The other standards will be seen as supporting topics, which either lead to the critical areas or reinforce critical areas from previous grade levels. We do not look at the standards in isolation, but rather standards should be clustered together logically into units of instruction. Units are not domain-based, but allow for integration across domains to see the interconnectedness of mathematical ideas. For example, in the third grade unit that addresses addition and subtraction, we could include the standard for elapsed time because elapsed time problems are typically solved using these operations. We could also include the standard regarding scaled picture graphs and bar graphs because students will be asked to solve problems involving adding to, taking from, putting together, taking apart, or comparing situations represented in the graphs. When clustering standards into units, I recommend using the prioritization referenced in the PARCC Model Content Frameworks, which are included in your handout on pages 11 to 19. The Model Content Frameworks were updated in November 2012, with some slight changes to 8th grade and many changes for high school. The color coding guides us as to how much time we should be spending on each topic, with the green representing 70% of our year, blue representing about 20% of our year, and yellow representing about 10% of our year. This also helps us to see what order we may want to address these topics, as the lower priority topics may be placed toward the end of the year to make sure that the higher priority topics are addressed in time for the performance-based assessments that will occur about 75% of the way through the school year. In addition to the priorities, we consider the logical progression of topics within the grade levels. Grade level units should progress from the least complex to the most complex. Just like building a house, we see some content as foundational for other topics. We now have a new definition of rigor. It is a balance of three types of math standards. The conceptual standards are the foundation. Procedural, skill, and fluency standards take into account that students have developed conceptual understanding and are ready to use that understanding to develop procedures and strategies for mathematical calculations. Once students have developed both concepts and procedures, they can apply both to solving contextualized problems in applications. Applications can certainly be used throughout the learning process as contextualized situations are motivating. For example, if I ask you to picture 16, what pops into your head, the quantity or the numerical symbols? I bet most of us visualize the numerical symbols 1, 6. But if I ask you to picture 16 oranges, do you have a visual of the quantity 16? Is it organized maybe in an array of some kind, or grouped as a 10 and some 1s? It's easier to visualize quantities when you have a context for them. There are typically 5 ways to represent understanding in mathematics. Manipulatives are used quite often in the primary grades, but are really appropriate at all levels. Pictures are the next layer of abstraction because they're less tactile than manipulatives. We now actually have a new mode that is a blend of these two, the virtual manipulative. We need to keep in mind that virtual manipulatives are only manipulatives for the user who can manipulate them. For everyone else, they're a picture representation. We'll be expecting to see virtual manipulatives on both the PARCC and the Smarter Balanced assessments. The next modality is the written symbol, which is typically what we think of when we think math. Understanding the value of the symbols includes connecting them to the manipulative and picture models. When we read any articles regarding working with special education students, we see mention of the concrete, representational, abstract approach, which is really referencing these 3 modalities. But there are actually 2 more. Oral and written language gives students the opportunity to explain their thinking and demonstrate their reasoning, gives teachers a window into students' understanding. And real-world situations, which is really the point of mathematics, to make sense of our world. It's not merely that we can represent understanding in all these 5 ways, but that we can transfer between and among these representations. That demonstrates the depth of our understanding. When learning new concepts, it's important to understand one's preferred learning modality so that new material can be introduced in the appropriate format for the appropriate student. So let's look at an example of a conceptual standard. See that this one begins with the word understand. It's not merely that we want students to divide, but rather to divide with the understanding that there is a relationship between multiplication and division. And also we see that there's a multiplication between area and division. So we can use what we know about multiplication and area to help us find unknown side lengths. The next type of standards are the procedural standards. These build on the concepts that are already established. When examining most published math curricula, it appears that they rush through conceptual understandings to get to the procedural practice. However, without established concepts, procedures are rarely understood, which is why they may be forgotten. Students internalize the procedures that make sense to them. Teachers will often say that the biggest problem we have is that students don't know their math facts. That's not really the case. The biggest problem we have is that students do not know that numbers are composed of other numbers and that the operations are related to each other, which is why students do not know their math facts. We cannot solve these conceptual issues with procedural practice. So now let's look at an example of a procedural skill and fluency standard. Once students understand the relationships between multiplication and division, multiplication and addition, division and subtraction, and how all of these operations relate to area, fluency can be realized. But without these conceptual standards, the procedural standards do not come easily. The final type of standard applications can be the most challenging for students, as we're asking them to utilize both concepts and procedures to make sense of these real-world contexts. So now let's look at an application standard example. These application standards often cause students to use those multiple modes of representation to make sense of situations or provide evidence of learning. For example, in this one, use multiplication and division within 100 to solve word problems in situations involving equal groups, arrays, and measurement quantities. They reference using drawings and equations with a symbol for the unknown number to represent the problem. Now let's look at a sample problem. Delia has 4 packages of cupcakes. If each container holds 6 cupcakes, how many cupcakes does she have altogether? This is an example of an equal groups problem, and the diagram can be used to make an equation, or it can also be used to support the equation and justify why an equation is appropriate. Either way, the ability to show the relationship between these representations demonstrates comprehension of both the procedures of multiplication and the concepts. At this point, I'd like to pause to address any questions that have arisen thus far before proceeding to discuss unit design. We have one question. Where is a good place to look for word problems of this kind? And I would suggest one site that you could go to is www.thinkingblocks.com. Thinking Blocks allows you to make visual models to solve word problems and connect those visual models to equations. Also, there's lots of books out on model drawing or bar modeling. The standards refer to those as tape diagrams. Those are good reference points. You can go to www.illustrativemathematics.org, and that is a wonderful resource for all types of examples of the standards. So one of the first steps in curriculum design is really to get to know the standards. And we do this by unpacking the standards. This is a great process because we can see that within one standard there are many targets that a student needs to be able to accomplish to meet that standard. And sometimes we think we're doing them, and when we realize that there are several aspects to the standard, we may be doing a portion of the standard, but not all of the standard. In doing this, it's important to stay true to the verbs that are in the standards. If it says to compare, our target for students should not be identifying, because that is a different level of complexity than called for in the standards. Usually we try to keep the verbs consistent, but when we see understand as our verb, we might want to say how we want to represent understandings in our targets. Then when we're looking at our standards, it's really helpful to think about what type of a standard is each. So The type of standard will help us to know a little bit more about which assessment and instructional strategies would be appropriate. If it's a conceptual standard, if it's a procedural skill or fluency standard, or is it an application standard, that will change the way we approach our instruction and our assessment. When we're unpacking, it